morning everyone, welcome back to Question a Day. Today I'll be answering the July 27th question on binomial probability. This question, we have this bit of a setup. Kirk and Les regularly play each other at darts. The probability that Kirk wins any game is 0.3, and the probability, we want to find the probability that in a match of 15 games, Kirk wins, and then we have various criteria here. Now, before we start this, we need to work out what type of distribution we're using. Now, we have been told it's binomial here, and binomial is the only distribution we know so far, so it's probably going to be that. But let's just check that we can actually use it. That's what's being talked about by this assumptions section here. So, the first condition is that we need two options, or two outcomes. Now, in this case, we have wins and not wins. Now, not wins is slightly different to losing, because we could win, draw, or lose. So here we have either the probability that we win, so probability of win, and a probability of not win. And that not win kind of encapsulates all the other possible outcomes. So basically he loses or draws. So there we go, that's our first assumption that we need to meet. We need to make sure that there's only two possible outcomes. The next assumption we need to meet is a fixed number of trials. Now, the binomial distribution only works if we know how many times an event takes place, or a trial takes place. Here we're told there's 15 games, so we say our fixed number of trials is 15. Trials is 15. Another thing we need to consider is the probability. So this probability of 0.3 for the binomial to work cannot change between trials. So we can't say one day have Kirk having a probability of 0.3 of winning and another day him having a probability of 0.5 of winning. That probability must always stay the same for every game. So that's another assumption we've made. We also can't assume that the outcomes of previous games, we have to assume the outcomes of previous games do not affect the outcomes of future games. Now this might, you could argue that this is an inappropriate assumption. Maybe after Kirk plays 15 games, he's getting better, and that probability of winning a game might increase. For the binomial, we must assume that that is not the case, that this probability is always the same at 0.3. So that's the main assumptions. And we'll talk about how we can then calculate each of these options. So, we need to set this up as a binomial distribution. The way we write this is we choose our variable, we'll call it x, and x is going to represent the number of successes. And this is going to be distributed by, so this tilde, that symbol's called, that squiggle. So x is our number of wins, tilde says is distributed as, or follows the distribution of. Capital B for binomial. And then we're going to put a couple of numbers in here. So binomial is defined by the number of trials and the probability of success. So if you remember the order that this goes in, we put the number of trials here, and then the probability of success is 0.3 there. So we have x tilde b brackets 15, 0.3, close brackets. That's telling us the number of wins is given by the distribution binomial, with 15 trials and a probability 0.3 of success. Great, so that's what we need to program into our calculator as well for the next step, but that is what we're working with. So now, I want to know the probability that Kirk wins exactly 5 games. So the way we write this is we say that the probability, we want the probability that x is exactly equal to 5. Now we can use our calculator set in binomial PD to tell us this, we put in our 15 and our 0.3 and say x is equal to 5. That's a probability of 5 wins, which comes out to be 0.2061. Okay. Next, we want to know that he wins fewer than half of the games. Now, half of the games of 15, and that would be 7.5 games. So we want to know the probability that x is less than 7.5. Now, that doesn't really make sense in this context. You can't win half a game. And that's because the binomial distribution models discrete events. We can't have half a game of darts. So really, what we're actually asking is the probability that x is less than or equal to 7 wins. If he wins 7 or less games, that fits our condition of that fewer than half of the games have been won. If he wins 8, that doesn't match the condition. So this is where we want to use our binomial CD, our cumulative distribution. We would go in, we would program in our data again, we'd put in 15 0.3, and we'd set x as being less than or equal to 7. And we calculate this, and this comes out to be 0.94999, and it rounds up to 0.95 as our probability there. So it's very, very, very likely here that that Kirk will win less than or equal to 7. He'll win less than half the games. Last of all, we want to know the probability that Kirk wins more than 2 games, but fewer than 7 games. So, just see my pen across the screen, but hopefully that's okay. What we're looking for here is the probability that 2 wins is less than x, so we're winning more than 2, but also less than 7. Now you notice there isn't a button to do this on your calculator, so we're going to have to be a bit clever how we work this out. We can think about all the options of what Kirk can win. Win 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. So just listed those number of possibilities. And the ones that fit this inequality, well, we want it to be more than 2, so we want 3 or above, and less than 7, so 6 or below. We need to come up with a way to write Kirk wins 3, 4, 5, and 6 games in one set of inequalities. Now we could take the brute force approach. We could say this is going to be equal to the probability that x is equal to 3 plus the probability that x equals 4 plus 5 and 6. And that would get us the answer. But that's quite tedious. That's four calculations we need to do, and we have to add them all correctly. And if that was an even bigger thing, say we wanted 3 to 12, that's quite a lot of calculation. So we might want a slightly quicker way. And we can do this using our less than or equals 2's. So we can think about, well, I want this to be less than 7, which means I can look at the probability that, well, less than 7 is the same as less than or equal to 6. And that probability that x is less than or equal to 6, well, that's the numbers 6, 5, 4, 3, 2, 1, 0. That's kind of cut off the top half. So we've got the probability that x is less than or equal to 6 getting us most of the way there. However, as you can see from these numbers I've drawn, we're still getting 0, 1 and 2. So we want to remove those as well. The way we do that as well, we've got 6 kind of downwards to 0. Well, let's get rid of 2, 1 and 0. So we're going to subtract 2 downwards to 0, which is represented by the probability that x is less than or equal to 2. So this way we eliminate 7 and above and 2 and below. And that's now 2 calculations that we need to make, which is a lot simpler than the 4 we needed, or the possible 10, 11 different calculations. Now we put this into our calculator, we get these two values. We get 0.8689 as our probability that x is less than or equal to 6. And for the probability that x is less than or equal to 2, we're going to subtract 0.1268. And we do this subtraction and we should be left with 0.7421. And that is our probability that the number of wins is more than 2 but fewer than 7. That's all for today, and I'll see you tomorrow.